In this video, we're going to talk about a couple of different topics. How to handle leap years and day of the year when you're doing long-term data comparisons. So say, for example, you have weather data that spans a couple hundred years, and every 4 years you have a leap year. So you got 365 days in a normal year, 366 in a leap year. And so the 60th day is February 29th, which only occurs every 4 years. So we want to label the days as day of the year from 1 to 366. I'm going to show how that's done. And I'm going to use an example from Germany. So we hit, to start off with here, we have this monitoring station, which is one of my favorites from Germany because there's over 200 years of data, pretty continuous data record. If we zoom in here, take a look at where this is. It's in Jena. And let's switch over to a different type of map, a satellite map. And I don't know what this facility is, but here's the monitoring station. And this beautiful monitoring station has over 200, almost 200 years of data from 1824. And you see 2024, we're not quite there yet, but we're approaching 2 centuries of data. This is a visualization of the number of records per year. And we can see it's very steady, the dark red being leap years and the orange being non-leap years. And so there is some missing data here and there, but for a large portion of it, we have 366 in the red bands, 365 in the orange bands. And so when we look at the raw data from that time period, there's a lot of data points here. So for this one monitoring station, we have over 70,323 individual daily maximum temperature readings. And so what I'm going to do is a couple of interesting animations. I'm curious to see, with this much variation, how has temperatures changed over time. And so what I did was I set up, I've got a term in here called day of the year 366, which is each day of the year. January 1st is 1, January 2nd is 2, all the way over to 366. For leap years, of course, day 60 would be populated with February 29th. For non-leap years, it would be empty. So I've built this animation with each month here, February, January, February, and so on, and day of the year coming across so that we have continuous field to show what we're looking at, which is, this is a 7-day moving average of maximum daily temperature in degrees F from starting in 1830. So I've got the data starting in 1830. And what I've done also is I've created a term here called every 10 years. So every 10 years means only show every 10 years. So if I move the page command 1 notch, it's going to jump to 1840. 1850, 1860, so that it's animating every decade. So what we're looking at is each decade being animated every 10 years, with the gray background being what happened in the previous years. It's basically the trails of the marks from the previous decades. So this is the last one in 2020. And how did I do that every 10 years? Well, the every 10 years looks like this. It's just a modulo operator. Take the year divided by 10, and then pick only the value of 0. That'll start it at 1830. If I pick the value of 1, it would start it at 1831, and then it would do 1841, 1851. So you have a choice. You could pick any of the intermediate ones if you want, but because I wanted even numbers, I started with 0. Pick 0 only for that function. Another way to do that would be to say, make this, wrap this in parentheses equal to 0, and then that's going to become a 1 or a 0, and then you would just have that as a filter, just pick the value of 1, and it would give you every 10 years. So that's a couple of different ways of getting what you want in terms of the animation. Now, the reason I did this was I wanted to be able to compare an initial time period to a later time period to a later time period. So if we look at that, we can see in the month of January, these are the daily readings with an average of 22 degrees Fahrenheit, 1830. By the time you go 100 and what is that? 150 years, it's up to 32 degrees. So it rose 10 degrees in 150 years. And then in the last 40 years, it went from 32 to 45. So it's gone up another 13 degrees in the last 40 years. And it's this time period from 1980 to 2020 that I've been working my global warming calculations within. And so I can given any monitoring station from around the world, I could create this type of plot, and I can quickly visualize what's the average monthly temperature in the beginning period to the ending period. And of course, I've got all these to choose from. I can always add another one if we wanted to put the year 2000 in there. We could do that, and we could put 2000 in the correct position here. So that's what we have as far as being able to visualize and animate at a station temperature change over time. And this, of course, is a daily record aggregated by month, or not really aggregated, but bucketed by month or partitioned by month. And then, so how did I do this in Alteryx? So let's talk about how do you get the day of the year in Tableau. First of all, you could do the day of the year in Tableau pretty simply. If you have a date field in Tableau, you just do a date part of, in the in quotes, day of year, end quotes, and then whatever the date is. So this is kind of what it looks like right there. You just have a date part. The day of year is the function, or is the date part, and then whatever your date is. So that's easy to do in Tableau. Now in Alteryx, I wanted to do a little bit more. I wanted to align each day of the year accordingly. So whether it's or not it's a leap year. So I don't want, for example, day 60 to represent February 29th in a leap year, and day 60 to represent March 1st in a non-leap year. So what I did was I wrote a little formulation in Alteryx to do that. How did I do it? Well, I started off with, I have a date field, and I wanted to just simply get the day of the year. And to get that, you just use a %J. So you use the datetime tool, set the day of the year, you use a %J down here as the custom format for the column. And so the date of January 2nd, 2000, shown in the lower left here, it gives you an output of 002. The next function I'm using here is going to basically extract the year for me. So that's pretty straightforward. I've got the date, and all I want is the year as a %Y. So now I have the year. So to do the mathematics of the alignment of the day of the year, it's pretty simple to do. First thing I did was I created a variable called temp day of the year, which is just simply, I'm going to trim off the zero. So I do a trim left 0 to get rid of the leading zeros of the day of the year. Then I'm converting it to a number. So 001 becomes 1. The next thing I do is take a look at the leap year. So I'm saying if it's not the mod of the year divided by 4, then that's a leap year. And then, so if it's a leap year, then because the leap year goes up to day 366, then I'm just going to take whatever the day of the year calculated was. So it's going to go from 1 to 366. Otherwise, if the temp day of the year is less than or equal to 59, then use the computed day of the year. So that's going to go from 1 to 59. They'll stay the same. Otherwise, take the day of the year and add 1. So what that means is in non-leap years, once you exceed February 28th, March 1st is not going to be day 60, it's going to be day 61. And so that aligns all the days of the year, whether it's a leap year or not. And so that's what's getting written out into Tableau so that I can create those animations where I don't have to worry about whether or not it's a leap year. All the days will be perfectly aligned in this condition over many hundreds of years. So that's a little leap year handling in Alteryx and Tableau, a little bit of data visualization, and thanks for listening. Talk to you later.